As k goes to infinity, this goes to, as k goes to infinity, this goes to, the infinity of infinity is what, Mr. Harris? Zero! Because he is the grand poobah. Oh! I thought we had cleared this matter a long time ago. Apparently not. That's why we have to do this thing called L'Hopital. Yes! He says you have a death match going on. Who's winning? Where's the grand poobah? You can't just say infinity of infinity is 1. I'm sorry. Infinity of infinity is what? Infinity. Infinity over infinity is what? 0. That was at 9:35. As k goes to infinity, this goes to infinity. As k goes to infinity, this goes to infinity. What is the limit of infinity over infinity? 2/3 at 9:36 a.m. You will never tell me that infinity over infinity is infinity without doing a L'Hopital rule again, will you?
No.
No. Why do you think I taught you? Oh, I mentioned something about, I don't know what I taught you, but I didn't mention it. L'Hopital's rule. When you have an indeterminate limit, then who knows who's winning? Huh? Who knows who's winning? That is to say, the limit as x goes to infinity of x squared plus 1 over 2x squared. Now you can go down to your pre-calculus when they say 1/2. They know something about degree of numerator and blah 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 blah. But we know something about infinity over infinity. We say L'Hopital. Yes. That is to say, you will have to take the derivative of this, take the derivative of this, and now you will let your k x go to infinity. As x goes to infinity, this goes to infinity. As x goes to infinity, this goes to infinity. Well, you can see it's 1/2. If you want to push the game though, you can say L'Hopital again. Infinity over infinity, L'Hopital. Differentiate this, and now let x go to infinity. What is the point of L'Hopital? It's to sort out this nonsense. Else you would never tell me that infinity over infinity is 1 without doing a L'Hopital. Do you have it? Good. Where? Have I chastised you enough? Have I berated you enough?
I think I got it now.
If you don't, I don't know when you will. Who will tell me what is the limit? What series did you what sequence did you what sequence did you compare this with?
2 raised to the I over 3 raised to the I.
2/3 to the power I.
Oh yeah.
So you want to compare. Oh, this is a serious L'Hopital. Huh? This is a serious L'Hopital. Mr. Harris, you will see. Infinity over infinity. Well, you're lucky that today it's 1. And what is BK? Well, you can take the numerator and divide it by 3 to the power I, and take the denominator and divide it by 3 to the power I, you will get the same thing. What? Divide top and bottom by? Huh? This is how I, very good. This is called doing some algebra. As I goes to infinity, this is going to go to Mr. Harris, infinity over infinity is what?
Today it's 1.
Oh, the grand poobah is here.
Oh,
Yes, he happens to be exponential and he happens to be a straight line.
Oh, I thought it was 3 I didn't see the it was raised to I.
Mr. Harris. That one, there is no need for anything. It's determinate. 1 over infinity is 0. So this starts to behave like, when I is big, this starts to look like what? Miss Howe, 2/3 to the power I. Clear. When I is big, this guy is huge. And so he says to this guy, ta-ta. And when I is big, this guy says, you are just 1. Welcome to 0. So when I is big, the sequence starts to look like this. Mr. Harris is not convinced. He wants me to show him that infinity over infinity is 0. Why is this 0, Dr. J? He will say. Why is the limit as I goes to infinity of I over 3 to the power I equal to 0? I thought infinity over infinity is 1. I will have to do a L'Hopital. Are you with me, Mr. Harris?
Yes.
But I can see it. This guy is going to infinity much faster than this guy. Is it okay if I change it to x because I want to differentiate? And now you know that when x goes to infinity, x goes to infinity. And when x goes to infinity, 3 to the power x goes to infinity. So this is an indeterminate form. It's not 1. It's not infinity. It's not 2/3. Who knows? We have an infinity over infinity L'Hopital. That is to say, take the derivative of the numerator and the derivative of the denominator, then try the numerator. Maybe things will have simplified for you. And the derivative of the numerator is what?
1.
Mr. Rubino, what is the derivative of the denominator? Mr. Rubino, what is the derivative of the denominator? ln 3 to the power x, huh? You all know your calculus 1 derivatives. Good for you. ln 3 to the power x. Now, as x goes to infinity, this goes to
1.
and this goes to, and then 1 over infinity is not indeterminate. Did I tell you that? Good. What is it? This goes to 0. This goes to 0. This goes to the power I. In other words, when I take the limit of this with 2/3 to the power I will get what limit? What is my L? 1. So in other words, these two are the same. No, why not do that way? I'll do that. Oh, goodness. I'm sorry, it should have been I. It should have been I also. I'm going to take this one and divide it by this one, and then let I go to. I'm going to get what number? Call us. What number? 1. They're the same eventually. You can see it. Let me do it formally.
Yeah, I told you it was 1.
I'm sorry?
I told you it was 1.
Mr. Harris, I have no rebuttal.
No, I get what you're saying though.
Yes. You can arrive at the right answer by making 2 errors. The one the answer should be plus and you do minus minus, you'll be correct. Say head north and then head south. You will head south. The limit that I will infinity of theta